Good morning, students. Welcome to 10th Science, Unit 10, Types of Chemical Reactions, Part 4. Now let us recall what we learnt in the previous classes. Introduction of chemical reactions, types of chemical reactions based on the nature of rearrangement of atoms, then types of chemical reactions based on the direction of the reaction and the rate of a chemical reactions. Now we pass on to the next topic, state of equilibrium or equilibrium state. Now let us consider the following equation. Phosphorus pentachloride, it decomposes into phosphorus trichloride and chlorine, and this is called as a forward reaction. And the combination of phosphorus trichloride and chlorine, they combine together to form phosphorus pentachloride, and this is called as a backward reaction. So it is a reversible reaction. Both forward and backward reactions take place simultaneously. Initially, the rate of the forward reaction is greater than the rate of the backward reaction. At certain stage, the rate of both the reactant and the product remains same. Here, there is no change in the concentration of both the reactant and the product. So, when the rate of the forward reaction becomes equal to the rate of the backward reaction, or the speed of the forward reactions become equal to the speed of the backward reaction, then no more product is formed, and this stage of the reaction is called equilibrium state. Now, what is chemical equilibrium? So, the equilibrium takes place in a chemical reaction. So, it is a state of a reversible chemical reaction in which no change in the amount of the reactants and products that takes place. So, at the equilibrium, the rate of the forward reaction is equal to the rate of the backward reaction. So, this chemical equilibrium can be explained by the following equation, the calcium carbonate. So, the chemical reaction that takes place in a closed vessel. Decomposition of calcium carbonate, it is decomposes into calcium oxide. It is also called as lime and carbon dioxide. So, this is a forward reaction. And this calcium oxide and carbon dioxide, they combine together to form calcium carbonate. So, this is a backward reaction. So, let us consider the decomposition of calcium carbonate into lime, that is calcium oxide and carbon dioxide. So, it is a reversible reaction. So, the speed of the reaction or the rate of the reaction can be determined by how quickly the reactant disappears. Here, which is the reactant? Calcium carbonate is the reactant. So, if the reaction is carried out in a closed vessel, it reaches a chemical equilibrium. So, the rate of the decomposition of calcium carbonate, this is a reactant, it is equal to the rate of the combination of calcium oxide and carbon dioxide. So, it is the product. So, calcium oxide and carbon dioxide are called as the product. Both of the rate or the speed becomes equal. So, the equilibrium, it takes place in the physical changes also. Here, now come to the picture. The water is in a liquid state. So, when the water is kept in a closed vessel, first the water is in a liquid state. And it is in a closed vessel means it changes into water vapor. So, now the water is called as water is in a gaseous state. Now, come to the next one. It is an intermediate state. Okay, here the forward reaction and also the water molecules, it evaporates, and the molecules that vapor, they come down as liquid. So the last one, that is in a equilibrium state. Now come to the water. Water is in a liquid state. Now water, it changes into water vapor. It is called as evaporation. This water vapor again condenses into water. So this process is called as condensation. So water is kept in a closed vessel. It evaporates and it forms water vapor. No water vapor escapes out of the container because this process takes place in a closed vessel. So the rate of the condensation reaction becomes equal to the rate of the evaporation reaction. So the process, they attains equilibrium. At this stage, the volume of the liquid and the gaseous phases remains constant. So this change is called as a physical change, and this equilibrium, this attained, is called as physical equilibrium. So what is physical equilibrium means? At the particular stage, the volume of a liquid and the gaseous phases remains constant, and the change is called as a physical change, and the equilibrium attained is called as physical equilibrium. Now what are the characteristics of equilibrium? The first point, in a chemical equilibrium, the rate of the forward reaction or the speed of the forward reaction and the backward reactions are equal. Second point, the observable properties such as pressure, concentration, color, density, viscosity means thickness, etc. of the system remains unchanged within a time. Within a time interval, the physical properties remains unchanged. Third point, the chemical equilibrium is a dynamic equilibrium because both the forward and the backward reactions continue to occur, though it appears static externally. Static means it's not moving. It is in an equilibrium state. The fourth point, in physical equilibrium, the volume of all the phases remains constant. So these are the characteristics of equilibrium. Now, the next topic is ionic product of water. Pure water is considered as a non-conductor of electricity. But if you pass electricity in water means it split into ions. H2O, it split into H plus and OH minus ions. So, the self-ionization or auto-ionization is a reaction in which two like molecules H2O and H2O, two molecules of water, they react to give ions. For example, H2O plus H2O, and this H2O is split into H plus and OH minus. H plus is called as proton. This proton, it dissolves in this water molecules to form H3O plus, and this H3O plus is called as hydronium ion plus OH minus, and this is called as hydroxyl ion. So the proton that gets dissolved in water and it forming hydronium ion, that is H3O plus and plus OH minus ion. So the hydronium ion is formed is called as a strong acid, and the hydroxyl ion is a strong base. So what is called ionic product of water? The product of the concentration of hydronium ion and hydroxyl ion is called as ionic product of water. It is denoted as Kw. Kw means ionic product of water, and it mathematically expressed as follows. So Kw, the ionic product of water, it is the product of hydronium ion H3O plus and OH minus hydroxyl ion, and it may be expressed like this also, the Kw equal to H plus. One molecule of water means it split into ions H plus plus OH, H plus and OH minus. The product of H plus and OH minus ions. So the H3O plus may be simply written as H plus. H plus means it is a proton. So the ionic product of water can be expressed as the product of hydronium ion, that is H3O plus, and the hydroxyl ion OH minus. And its unit is mole per square and also dm minus 6. But at 25 degrees Celsius, its value is 1.00 into 10 power minus 40. The next topic, that is called pH scale. So pH scale means it is a scale measuring the hydrogen ion concentration. Hydrogen ion means H plus ion concentration in a solution. So pH scale is the power of hydrogen ion concentration in a solution. pH stands for potence in German, meaning power. So you have to find the power of hydrogen ion concentration in a given solution. pH notation was devised by the scientist Danish biochemist Sorensen in the year 1909. So the pH scale is a set of numbers from 0 to 14. Come to the picture, 0 to 14. The value, pH value 0 to 7 means pH, the nature of the solution is acidic. If the pH value is equal to 7 means it is neutral. And the pH value is greater than 7, 8 to 14 means the nature of the solution is basic or alkaline. So acids have pH less than 7. pH value less than 7 means the solution is acidic. And pH value greater than 7 means it is basic. And pH is equal to 7 means it is a neutral solution. So pH value only decide whether the solution is acidic or basic or neutral. pH is equal to minus log of OH H plus. pH is equal to minus log of H plus to the base 10. Now you come to next one, pH paper. pH paper, what does pH paper means? pH paper contains a mixture of indicators. Now come to the picture. This is a universal indicator pH color chart. Here some of the color chart and their values also given, and the nature of the solution is also given. It is an acidic or basic or neutral. So you have to test it by using a solution, and it is compared with the pH chart. So pH, what does pH paper means? pH paper contains a mixture of indicators. The test solution is tested using a drop of a universal indicator or a drop of a test solution. A test solution is put it on a pH paper. What happens means the pH paper changes its color. If it changes into red in color means the pH value equal to 4. The nature of the solution is acidic. Sometimes it changes its color into green means the pH value is equal to 7. The nature of the solution is neutral. And it changes into blue in color means its value is equal to 9. The nature of the solution is basic. So the color of the solution on the pH paper is compared with the above pH chart. So what does pH paper means? It contains a mixture of indicators. Now come to the last topic of this lesson, role of pH in everyday life. Are plants and animals, they have pH sensitive? Our body works with a pH range of 7 to 7.8. Here, the living organisms also can survive only the narrow range of pH changes. So, different body fluids have different pH values. For example, the pH of blood is ranging from 7.35 to 7.45. Any increase or decrease in this value, it leads to diseases. The ideal pH for blood is 7.4. What is the meaning of ideal? Means the correct pH of blood is 7.4. Second one, pH in our digestive system. And here, it is very interesting to note that the stomach produces an acid. That acid is called as a hydrochloric acid. This acid helps in the digestion of the food without harming the stomach. So during indigestion, the stomach produces too much acid, and also this causes pain and also irritation. So what happens here means the stomach, it produces the hydrochloric acid. The stomach fluid is, pH of stomach fluid is approximately 2.0 or 2. Now pH changes as the cause of tooth decay. So the pH of saliva, the saliva ranges normally from between 6.5 to 7.5. When the pH of the mouth saliva falls down or below 5.5 means the enamel gets weathered. So the toothpaste, you already know that it's generally basic. It is used for cleaning the teeth and can neutralize the excess acid, and it prevents the tooth decay. Now, pH in soil. In agriculture, the pH of the soil is very, very important. Citrus fruits. What are citrus fruits? Lemon, orange. So, these are citrus fruit. The citrus fruits, they require slightly alkaline soil. They need basic soil, while the rice requires acidic soil, and the sugarcane requires the neutral soil, both acidic or neutral. Then pH of rainwater. The pH of rainwater is less than 7. The atmospheric air is polluted with the oxides of gases such as sulfur and nitrogen, sulfur dioxide, nitrogen dioxide. So it polluted with the atmospheric air. What happens means they get dissolved in rainwater, and the value, it makes the pH value less than 7. So if the pH of rainwater is less than 7, and it is called as acid rain. So these are the points to remember the role of pH in everyday life. Okay students, thank you.